Coming to the second part of the module 1 content, we will discuss in detail about the further requirements of the energy resources of our plant. So in the energy resources here we have got solar energy, wind energy, tidal energy, idle energy, ocean thermal energy. So here what all it looks like is the what all the different type of energies are available, which are produced continuously in nature and are essentially inexhaustible at least in the time frame of human societies. So here solar energy, wind energy, tidal energy, hydel energy, ocean thermal energy is there. So non-renewable energies are fossil fuels, nuclear fuels. So here it is there, which have been accumulated over the ages and not quickly replenishable when they are exhausted. So if you take a solar plant, how it is going to reach the house if you have a solar cell is. So here you are going to have the solar panel, it will be having an inverter, it will be having a disconnect button, so there will be an AC, a disconnect switch, so there will be a PV generator meter, so there will be a utility meter. So like this, it will be continuously monitored by the meter which is present, and it will be circulated again and again. So this is how a solar power plant it is going to work. So apart from the energy produced, we'll be able to take the solar energy which has to be produced and you'll be able to go ahead. So here solar flat plate collector. So here there will be a thermal insulation followed by tubes. So there will be a black absorber plate. So there will be transparent screens. So apart from the transparency, there will be a black absorber plate. So there will be fluid tubes. So there will be thermal insulation. It will be able to go. So there will be a transparent screens. So the transparent screen will be able to avoid and absorb on the solar plate. So there will be a black absorber plate which will be present on the surface. So like this the solar panel it is going to work. So if you take the wind energy it has got blades which has got a motor for which it has got a coupling. So there will be an indicator of the air which is going to flow. There will be a at the extension provided, it indicates how what way the air is flowing and how it works. So here there will be a base attachment which it has to be done and it has to be taken care. So here if you see the inner parts of the blade, here how it looks, here this is how the parts are going to work. So here you can see how the system is going to work. So here the brake system is there, so blade is there, so for which you are going to attach. So generator will be there, so there will be a gearbox, so there will be a low speed shaft which it has to be connected, and the motion it is going to happen. So wherever the air blows, initially it is going to show the direction by the wind vane, how the air blade it is moving. So hydropower plant it will be having a reservoir stock, there will be a dam, so there will be a surge tank where pressure flows from the tunnel to the valve house. So there will be a penstock and power station, and there will be a tail rise, so it keeps on moving. So here reservoir will be there. So here it will be the reservoir, how the power is developed, and it will be distributed to different systems. So thermal power plant, this is the black diagram of how a thermal power plant works. So there will be two towers, one it will be the cooling tower and another is the stake. So in between those two you will be able to see electric generator, turbine and a boiler. So there will be a fuel air which will be admitted to the boiler. So there will be a turbine. So there will be a condenser. There will be a warm water. So there will be electric generator. So it keeps on moving. So if you take a nuclear power plant, so there will be a concrete shield. So it will be covered. by the condenser, and there'll be a thermal sheet will be there, so there'll be a heater core, and it will be having a evaporator tube, evaporator or a boiler will be there. So there exchange is going to happen, then it is going to store in the turbine, and there'll be a condenser, so there'll be a fuel pump. So there'll be a fuel pump. So like this, a nuclear power station is going to work. So further, if you take, it is another type of power generation system where it will be having a control system where there will be a nuclear fusion reaction happens. So from the steam, the pump is going to move out with the turbine. So water rate is going to move, generator is there, so that will be a cooling tower. So there will be a tidal power. If you take tidal power, water is at the high tide, so there will be lower level tide, so there will be high tide and low tide. So the energy, when the water moves from the dam, so there will be able to get the energy. So these are all some of the weblinks which we are supposed to see, the different aspects of checking out how the steam is produced, how the steam is used in manufacturing and process industry. These are supposed to see.